check solution. Summation series lesson 4. Alright, so we just want to enforce on the previous concept. Alright, so if you look at this one, we are saying summation of r equals to 1 up to n of a r plus or minus b. So this is a linear function. Will generate an arithmetic series. Alright, so let's look into this one. We are saying summation of r equals to 1 up to n 3r minus 1. So this is a linear function because r here is r to the power 1 and 3 is a constant and minus 1 is a constant here. So we'll generate an arithmetic series. So let's start how this function is generating the terms here. So we have 2, 5 and 8 which are generated by this function, and we have the last term here. So you can see here from 2 to 5 there's 3 units, then from 5 to 8 there's 3 units. So this is the property of an arithmetic series. The terms, they are differing by constant value. So your first term here can be denoted by a, so a is equals to 2, then the common difference can be equals to 3. Right, so we can find the sum of this series, so using this formula. Right, so sum of the terms of an AP or arithmetic progression or arithmetic series here is equals to n over 2 a plus n minus 1 times d. A is the first term, d is the common difference, then n equals to number of terms. Alright, then sum up to, we can also use this formula, which is n over 2 a plus the last term. So a is the first term, then L is the last term. Alright, so let's look into the example here. Find summation from r equals to 1 up to 20 of 2 minus 3r. So you can see this one is it's a function which will generate an arithmetic series. Why? Because the highest power here of r is to the power 1, then 3 is a constant, and we have 2 here, so it will generate an arithmetic series. Right, so this is the arithmetic series. Your first term is minus 1. When you put r equals to 1 here, we get minus 1. R equals to 2, we get minus 4. R equals to 3, we get minus 7, plus and so on up to minus 58, which is the term number 20 when r equals to 20. Right, so now what can we do here? We can see that our first term here, a, is minus 1. That's the first term. Right, but remember, we also need the number of terms. The number of terms when you're calculating using this formula. Right, so the number of terms is equals to the last term minus the first term plus 1. So your last term is 20, then your first term is 1. So it's 20 minus 1 plus 1. So this will give us 20 terms. Right. Then the common difference is minus 3. Right. From minus 1 to minus 4, there's 3 units. You just subtract the consecutive terms here. You see the common difference. Minus 4 minus 1, it will give you minus 3. Minus 7 minus 4 will give you minus 3. So the consecutive terms, if you subtract them, they give you the common difference here. Alright, then now we can find the sum. So the sum here, we are saying it's n over 2 2a plus n minus 1 times d. So your 20 is your number of terms over 2, then 2 times minus 1 plus 20 minus 1 times the common difference here. So we are going to have 20 over 2, then we simplify. This will result in minus 590. Or you can use the second formula here, where we say it's n over 2 the last term, the first term plus the last term here. So the number of terms here, we have 20, so it's 20 over 2 minus plus minus 58. Your first term is minus 1 here, minus 1, that's your first term. Then your last term here is minus 58, which is going to give us minus 590. So this type example only applies when the series is generating an arithmetic series here. Alright, or we can use the standard results from the previous lesson. We are dealing with examples where we are using the standard results. Alright, so let's go to this one. Alright, so if we look at this expression, this is summation of r equals to 1 up to n a times b to the power r. So a and b are constant, and there's a power here r. So this is going to generate a geometric series. Alright, so let's look into this one. We have this one, summation of r equals to 1 up to n of 5 times 2 to the power r here, which is equals to, if we put r equals to 1, we get 5 times 2. Then if we put r equals to 2, we get 5 times 2 to the power 2. R equals to 3, we get 5 times 2 to the power 3. Alright, so let's start the pattern here. We are going to see that moving from the first term to the second term, there's a factor that is being multiplied here. So there's a multiplicative factor here. So 2 is being multiplied at the first term to get the second term. Then from this one, the second term to third term, we are also multiplying with 2. So that one is what we call the common ratio. Alright, so in this case, our first term a is equals to 10. 5 times 2 is 10 here. Then the ratio is 2. So the common ratio is 2. On a geometric, there's a ratio that is being multiplied on the previous term to get the next term. So to find the common ratio, just divide the terms which are consecutive here. So you can divide this one divided by this one, you can get 2. If you divide the third term and the second term, you can get also 2. That's how you find the common ratio. So we can find sum of terms of the series of a geometric here. How? By using this formula, right? So sum of n is equals to a, open brackets, 1 minus r to the power n, or over 1 minus r. A is your first term, then r here is the common ratio, then n is the number of terms. Right, so let's go to the example here. Alright, find summation from r equals to 5 up to 13 of 3 times half to the power r minus 1. So here it's a function or a generator which will generate the geometric series here. Alright, so let's go to the series here. So from r equals to 5 up to 13. So when r equals to 5, we are going to get the term on the series here, which is the first term per this question. Then when r equals to 6, we get the second term. When r equals to 7, we get this term. Then when r equals to 13, we get the last term. Right. So we can now see that our first term here is 3 times half to the power 4. And then what else do we need? We also need the common ratio. Or we also need the common ratio and the number of terms. So the number of terms, we said it is the last term minus the first term plus 1. So in this case, if we say 13 minus 5 plus 1, we get 9 terms. So there are 9 terms in this series. All right. Then you also need the common ratio. So the common ratio, we are just saying we divide the terms which are following each other. In a geometric series, we just divide the terms which are following each other. So in this case, if I say the second term divided by the first term, I'm going to get half. Or the third term divided by the second term, I'm going to get half here. So that's how you get the common ratio. Alright, so we can now find the sum of 9 terms here. Alright, so sum of 9 terms here is a open brackets 1 minus r to the power n over 1 minus r. So your a is this one. Then 1 minus r, your common ratio, to the power number of terms over 1 minus half, which is equals to 27 over 2. Right, so this is the sum of 9 terms of a geometric series which is given here. Alright, so thank you for watching the video. See you on the next lesson.